I'm going to ask for a simple, quick assessment, okay? I'm going to describe it, and then I'm going to ask you guys to do it. It's going to be, all of it is going to be based on components and functions that you guys have already used, all right? So I want you guys to start out by creating a grid, and it's a square grid, right? So create a square grid. Let me back that up. That is adjustable you're going to create a square grid that is adjustable, right? Tab. From 2 to 10 cells, all right? From 2 to 10 cells, so it's adjustable, so you're going to make it so that it goes from 2 to 10 cells. From 2 feet to 10 feet in size of the cells, in feet, okay? And I would like it to have be adjustable in the x direction from 1 to 10, and then I want it adjustable in the, actually we'll make it adjustable in the x and y directions. From 1 to 10, okay? So it's going to expand and contract from 1 to 10 in each direction, but make them so they're adjustable separately, all right? And the size of the grid will vary from 2 feet to 10 feet, okay? All right, so the next thing that I would like you guys to do is on each of the intersecting points, I want you to place a circle. All right, so place a circle at each of the intersecting points. All right, and we'll start with that. That's going to be the basic assessment. So I'm going to give you guys 15 minutes to do that. Shouldn't be too hard. Any questions? All right, go. I'm going to resume my my recording because I want to make sure that in the recording I show you what the outcome is. So the size is adjustable from 2 feet to 10 feet of the square. The number of squares goes from 1 wide to 10 and from 1 tall to 10. Okay? And right now we're just simply using the inherited value of radius for the circle. So some of you got this right away, some of you didn't. Some of you guys are still struggling with it. Some of you, since I asked you to construct point, deconstruct points so many times, you assumed that it had to be movable, but I never asked for that. Okay? So here's the next part of the challenge, so I'll write it up so you guys can see it. All right? So I want you, for the next part, let me start the recording. Or it's already recording. So I'm going to put a dash across here. All right? So part 2 of this is going to be make the circles so that they touch at the corners. no matter what size the grid is. Okay? So, and it needs to be automatic. All right, any questions about that? Let me pause this and I'll show you what the outcome needs to be, okay? All right, so no matter what I want it to automatically adjust no matter what the size is without having to do anything other than run my slider across. I don't want to have to change anything else. All I want to do is run my number slider back and forth, okay? I'll give you guys a hint. This has something to do with thinking about it mathematically. So you can see also that I can choose to decide how many cells I want in each direction, and it automatically populates with a mathematical value that sets the size of the circle so that they always touch. I'll give you one other hint. You only need 2 additional components to do this, and you've used both of them many times. So I'm going to ask this question for those of you that are struggling with trying to put this real simple definition together. What is the distance from that intersection to that intersection? The distance from this intersection to this intersection, look on your screen right now. How is that governed? Isn't it governed by a number slider? Yeah. All right, and so if you wanted to get something that was half of that distance, how would you get it?
Divided by 2.
So let's hypothetically say that that's 10. How do I get it to be half of that distance?
Divided by 2.
Divide by 2. Now what if it's 8? You still divide by 2. So think about that. The radius that you're looking for is half of the cell value of the grid. All right, so I'm going to resume this this little challenge, okay? And I am going to request that you guys go back through your notes. And this one's going to take much longer. I want you to go back through your notes, and I want you to establish a random number generator, okay? A random number generator that's going to have the ability to generate random numbers between 1 and 10. Okay, so I should type that up, right? Let me type that up. So within this definition, create a random number generator that will create values from 1 to 10. You need to build it inside of this definition. Okay? So I want it built within this definition, directly adjacent to the other component that you've done thus far. Any questions about that? You've already done a random number generator. I just want to make sure that you guys understand that the range for that random number generator, okay, is going to be values from 1 to 10. Okay? So go back. You guys were supposed to do this. You guys were supposed to print, right, all of your little sub definitions and have them in a book, if you guys did that and you opened it up to the page that had the random number generator, you would know how to do this. And it would be very easy. Now, if you didn't do what I asked you to do, now you're going to have to open up each of your definitions until you find the one that you remember has the random number generator. Okay? All right, so I'm stopping there. All right, so I'm going to show you guys how to do one more. I have to show you guys how to do one more component called extrude, which I really shouldn't have to show you how to do it, but I'm going to show you how to use it. Okay, and then you'll be able to create the definition that I've just recently shown you. So I'm going to stop this challenge, right, and we'll pick it up in part 2 of the challenge.